Hello everyone, welcome back to my channel. In our last discussion, we discussed the reliability and validity. In today's discussion, we are going to deal with the normality test. So we want to check if the data set is normally distributed. Now, how do we check if the data is normally distributed? In two ways. So we can use the graphical way to check if the data by using our eyes to observe whether it has outliers or not. And we can also use our statistical evidence. So let me explain to you when we use the graphical approach. Now we use histogram and then we check if the data is normally distributed. If when you perform the analysis or you generate your graphs and it has a long tail to the right, this a long tail, and then or to the left, that means the data is not normally distributed, which means it's skewed. So if it has the longer side to the left, it means it is negatively skewed. If it has the longer side to the right, it means it is positively skewed. And if the right and then the left, or the right and the left are the same, it means it's normally distributed. So this is how we use the graphical approach. And let's see the statistical evidence too. In the statistical evidence, we use the Shapiro, Wilk, and Kolmogorov, Smirnov. And then when you perform this one, what you observe, you check your p-value and then match it to 0.05. So if your p-value is greater than 0.05, it means the distribution of the data is normal, or the data is normally distributed. Otherwise, the data is not normally distributed. So the next question is, if the data is normally distributed, which statistical tests are best for you? And if the data is not normally distributed, which statistical tests are best for you? And now, these are the various tests. So if the data is not normally distributed and you want to compare mean value to a particular value, or the mean of the data to a particular value, if the data is normally distributed, you use one sample t-test. If the data is not normally distributed, you use the Wilkinson sign rank test. And then if you want to compare two independent groups, then you check if the data is normally distributed, you use some t-test of independence. You use t-test of independence. Otherwise, if it is not normally distributed, you use the Mann-Whitney U-test. If you want to compare means of, that's paired means, then you use paired sample t-test. And then if it does not meet the normality test, then you use the sign rank test. Then if you want to compare more than two independent groups, when the data is normally distributed, you use one-way ANOVA. Otherwise, you use Kruskal-Wallis H-test. Compare means of more than two related measurements, then you use the repeated measure of ANOVA. Otherwise, you use the Friedman. If you want to examine relationship between variables, if the data is normally distributed, you use Pearson correlation. Otherwise, you use Spearman's rank correlation. If you want to predict continuous variable, you use linear regression when the data is normally distributed. Otherwise, you use this one. So in that order. Now, this is what you need to know. Now let's take our data set and then check certain things and perform it and see how we can apply this particular information that I just explained. So we have our data sets here. Please, I will leave these data sets in the description. You can download and practice it. So now we have a lot of information here. but I want to consider this particular information, income and weight. I want to perform a test on them. They are the things I want to use for my further analysis, but I have to know whether this particular data set is normally distributed or not. So in order to do it, you have to go to Analyze. Then you come to the descriptive statistics. Then you move to Explore. So the data or the variable of interest, you push it to the dependent list. So our interest or variable of interest is the income. So you select the income and place it here. Then you go to plots. When you come to the plot, uncheck this one, you can use this one, use the histogram, and then also check normality plot with thesis. I think these are the only two things you need. Then you continue. Then you say okay. Now SPSS has displayed other information or a lot of information. So what you need here is the test of normality, and then the histogram. So now let's go to the test of normality. In the explanation section, I said when the p-value is greater than 0.05, it means that the data is normally distributed. Otherwise means when the data set is, when the p-value is less than or equal to 0.05, it means it's not normally distributed. Now let's see. When you check this one with the Kolmogorov, you could see that the p-value, that's the significance value here, is 0.001, which is less than 0.05. And when you come to this side to is 0.001, which is also less than 0.05. That means that this particular data set has violated the rule of normality. In other words, it does not meet the normality test. And for that matter, we use non-parametric test for our further analysis. Now let's see the histogram too. You realize that it has the longest of its tail to the right side. That means it has also confirmed this one, which means that it is positively skewed. It is not normal. If it were to be normal, most of the distribution should have been within this range. It should have looked like this. It should have looked like this, but you could see that it looked like this one. That means it is not normal. And for that matter, the objectives, if these are your objectives, you have to perform a test within this particular range. So that is basically what the normality is about. So now let's also perform the weight to see if it meets the normality assumption or not. So we go to Analyze as usual, Descriptive Statistics, Explore. We finish with the income, so we move down. Weight is what we are interested in now. We take it inside. Explore. The histogram is checked. Test normality plots with thesis are also checked. So you continue and then you say okay. Now we had our outputs being generated. So when you come here, we could see that our p-value here, you check this one, the test of normality for the weight. Our p-value here, 0.200, is greater than 0.05. That means that this particular data set is normally distributed. So we said when the p-value is greater than 0.05, it means the data set is, or the data is normally distributed. Otherwise, it is not. And 0.200 is greater than 0.05. That means that our weight data is normally distributed. So let's see what the histogram 2 says. you could see that the histogram to most, it's approximately the normal distribution. It's like this particular side is almost the same as the other side. So in otherwise, it looks like this one. It looks like this one. It doesn't have longest tail to the right, neither to the left. It has it this way, which means that it is normally distributed. And for that matter, you can go in for this particular test if these are your objectives. So one sample t-test, independent t-test, because sometimes you can perform some tests and then they ask you, why did you perform this test? The data also make a lot of decision. So now that you understand the normality test and how to make decision with it, let's see how we interpret our reports. So I already have this particular data. I have already worked with them. So let's see how it is being reported if this is your thesis. So now we have for the income, this is the report, the output we just generated from the SPSS. This is the report here in Word form. So you could see it has violated the normality assumption. Therefore, it is not normally distributed. And then supported by the p-value, which is less than 0.05. So let's see. The normality of the income variable was assessed using both graphical and statistical approach. A histogram was first examined to evaluate the shape of the distribution as shown in figure 1. So this becomes our figure 1. The income data exhibits positively skewed distribution with a concentration of observation at a lower income levels and a long tail extending towards the higher income values. So we have our higher income. These are the lowest income, so it has high tail to this side. The distribution deviates from the symmetrical, which means it's not bell-shaped, and expected under normality. The descriptive statistics further indicate substantial variability in income. So we have our descriptive statistics. Our mean is this, standard deviation is this. You can find it from here. So that is what we are explaining, which is consistent with the observed skewness. Now let's move to statistically assess normality. The Kolmogorov, Smirnov, and Shapiro Wilk tests were conducted, and the results. So now these are the results. So what did they say? Which is statistically significant, indicating that the data does not meet the normality. So based on the combined evidence from histogram and normality test, it is concluded that the income variable is not normally distributed. Consequently, the assumption of normality required for parametric analysis is violated, so we can't use the parametric. Therefore, non-parametric statistical techniques are considered more appropriate for subsequent analysis involving the income. So in a situation that maybe your supervisor wants it to follow the normality test, we can do something called transformation of the variable. So otherwise, you have to just go by the non-parametric. And now this is how we also report this one is normally distributed. And then we also have our statistical evidence supporting it. So we have, let me make the data clear so that So the normality of respondents' weight variable was examined using both graphical and statistical methods. A histogram was first inspected to assess the normality. So now, how do they suggest? So now this histogram here also tells the data is normally distributed. So that is what I just described here. So this particular information here just reflects what I was explaining to you here. So to statistically assess the assumption of normality, the Kolmogorov, Smirnov, and Shapiro tests were conducted with results presented in table 2. So this is our second table. That's why I call it table 2. The Kolmogorov yield statistical of 0.022. No, I made a mistake. It's not 0.022, it's 0.22. So it's typing mistake 220 with significance value of I'm coming. What did I do? Okay. I was referring to the significance with significant value of 0.200, while the Shapiro Wilk also has statistic of this with statistical value of this. In both cases, the p-value exceeded the 0.05 threshold, indicating that no statistical significance deviate from normality, which means that the data set is normally distributed. So based on the combination of this, we could tell that the data is normally distributed, and therefore we have to move further, or our further analysis should be based on parametric. That means that if these are our objectives, then the best methods should be this one. So I think now you understand the normality test. Please like, subscribe, and turn on the notifications such that you will not miss the important videos. Now we have finished with the reliability test and then our normality test. Our next one will start with the main thesis, starting from t-test and then one sample t-test, independent t-test, in that order. So please subscribe and follow as we learn together. Thank you.